Okay, now that we know what the parent function for tangent looks like, now we're going to do our transformations. I have 3 examples I want us to work through. The first equation is y equals 4 tangent x. So just like we did with sine and cosine, we're going to list our information. What is our amplitude? Well, if this was sine and cosine, we would say 4. But think about it. Does a tangent curve have height? If you look at your parent function, the tangent curve has an arrow on the end, which indicates it's going to go all the way up to positive infinity and all the way down to negative infinity. So this is a trick question. If you type in for amplitude for tangent 4, you're going to get marked wrong, because then you're saying it's only going to go as high as y is 4. So with tangent, there is no amplitude. Okay? You're never going to level off the height. Okay? What is the frequency? Well, the frequency is still the b, the number connected to the angle by multiplication. So the frequency is 1. What is the period? For tangent, how many degrees does it take to make a complete tangent curve? If we go back to the parent, from negative 90 to positive 90, the period is 180 degrees. So 180 divided by 1 is 180 degrees. So our period didn't change. Do we have a phase shift? Nothing is being added or subtracted to our angle, so we have no phase shift. Do we have a vertical shift? Nothing is being added or subtracted to the whole expression, so no shifting. So guys, this graph of 4 tangent x is going to look exactly like this graph of the parent, because nothing changed. Putting that 4 there, you're going to say, well, change the height, but we have no height. So this graph is going to look exactly like this. If the period's 180, you'd put your vertical asymptote at negative pi over 2. You'd put your vertical asymptote at positive pi over 2. Nothing shifted, so the point for the tangent curve should be in the middle, the origin. All that 4 is going to do is make this curve a little bit steeper. It may not be as wide. It may be a little bit narrow. So it would look something like that, where it narrows off. But that's it. All righty. Let's go to B in the notes. Y equals tangent x plus pi over 4. So again, when I ask you for the amplitude, what are you going to say? No amplitude. There is no height to a tangent curve. Do we have a frequency? We sure do. Frequency is 1. What does that make the period? For a tangent curve, you only need how many degrees? 180. So 180 divided by 1 is still 180. That's good. Okay? But now look, what's different here? Oh, we have a phase shift. We're adding pi over 4. So our phase shift is plus pi over 4. What does that mean to us in words? That means to us in words, this whole graph has got to move to the left. Pi over 4 is 45 degrees. All right? So the only difference between the parent, which is here, and the one we're about to graph is it's going to shift to the left. Now, this is what we're going to do. You remember with sine and cosine, we listed all 5 points for the period, and then we added or subtracted to make the shift? Well, with the tangent curve, you don't have 5 points. You have 2 asymptotes and 1 point. So when we have a normal tangent curve, the parent, we know the vertical asymptote is at negative 90 degrees, the point is at 0 degrees, and the other vertical asymptote is at 90. See my picture? My vertical asymptotes are at 90 and negative 90. My point is at the origin, which is at 0. So first of all, when we go to do our shifting, we're not going to have 5 numbers in the domain for the x's. We're only going to have 3. Because to graph a tangent curve, you need to know the 2 asymptotes and the point in the middle. So a normal tangent curve, that would be the setup. Now we're going to go to the left 45 degrees, which means we're going to subtract 45 degrees from each of these guys. Negative 90 minus negative 45 is a negative 135 degrees. 0 minus 45 is negative 45 degrees. 90 minus 45 is 45 degrees. So now you have your new locations. We know the first vertical asymptote here is 45. That's pi over 4. We know the point is going to be at negative 45 degrees, negative pi over 4. And we know 135 is how many 45s? How many times would you add 45 to make 135? 3. So this would be negative 3 pi over 4. So now you have your setup of your x-axis. So to graph this picture, I'm going to do it in red here. Here's my x-axis, here's my y-axis. Just like we talked about before. The period and the phase shift set up the x-axis. So now you have your x-axis. Okay? 45 degrees. That's 0. So I'm going to make sure I'm equidistant for your negative 45 degrees. So look, 45 degrees, skipped a line for 0, went to negative 45. So skip a line to go to negative 135. Everybody's good? First thing you're going to do is draw in your VA, your vertical asymptotes. Draw it down, draw it down. Your point is at negative 45 degrees. We didn't have any shifting up or down, so it stays right here. And then we draw our tangent curve. So everybody look, doesn't it make sense that we took the original, and if we shifted everything back 45 degrees, 90 would shift back to be at 45 degrees. It is. 0 would shift back to be at negative 45 degrees. It is. Negative 90 would shift back and be negative 135. Make sense? Good. All right, our last tangent curve. Again, let's look. If it asks for amplitude, what are y'all going to say? There is none. But I want everybody to look very closely in front of tangent. Tangent's not positive anymore. See, this tangent is positive. It's an increasing curve. This is positive. It should increase. This is positive. We should increase. Everybody look closely. What's your tangent here? Negative. We don't say the amplitude is negative 1. We don't say the amplitude is 1 for tangent. We just say there is no amplitude. But this negative means our picture is going to be a reflection. A reflection is a mirror image. So instead of tangent going up, if we look at it as a mirror image, it's going to go down. Okay? Now, do we have a frequency? Sure. Our frequency here is 1. If our frequency is 1, our period is going to stay how many degrees? Good, it's going to stay 180. 180 divided by 1 is 180. Do we have a phase shift? Well, here's my angle X. There is nothing being added or subtracted here, so there is no phase shift. Okay? Phase shift, there is none. All right? But now we have a number in the front of our trig function, which means we have a vertical shift. If the number is negative 1, it means this whole picture is shifting down 1. All right, so let's see how we graph that. All right, so let me set up an XY axis. Okay, by knowing the period's 180 tells me that our vertical asymptote should be at negative 90 degrees, our point should be at 0 degrees, and our other vertical asymptote should be at positive 90. There is no phase shift, so this is not moving. Y'all with me? So that's set. That is our x-axis. So negative 90 is negative pi over 2. Here's 0, and here's positive 90. That's for sure is set. Okay? There is no phase shift, so we're not moving. So I could draw my vertical asymptotes in. Okay? Now, here's the problem. The point should be at 0, 0. But you have a shift of down 1. So remember, when we talk about a vertical shift, we go to negative 1. Okay? And we draw in that dotted line, that sinusoidal axis. So instead of the tangent curve revolving here around the origin, it's going to revolve around here. So think about it. On a normal tangent curve, the point should be 0, 0, but now it's moving down 1. So now your point is at 0, negative 1. Now, the only other thing we got to take into account for is this negative, which is a reflection. Normally a tangent curve goes from left to right and increases. Well, a reflection means it's going to go in the opposite direction. So instead of being increasing, it's going to be decreasing. So if you start at the left, you're going to go down. So watch, I'm following my asymptote. I'm following my asymptote. I'm going to go down to this point, and then I'm going to curve and keep going down. And that would be the picture of y equals -1 minus tangent x. So the same transformations we talked about with sine and cosine, we could do with tangent. Okay, next video is coming about cotangent. Catch you then.